Hello everyone, welcome to the continuation of our series of tutorials on the exponential equations. Here we have another exponential equation to solve for x. 12 to the power x minus 16 to the power x is equal to 3 to the power x minus 4 to the power x. Here we have 3, here we have 4, and if we look at 12 and 16, we see clearly that 3 and 4 are factors of 12 and 4 is a factor of 16. So let's change 12 to product of 3 and 4. So this one will be written as 3 times 4. Since 12 was raised to the power 12, we raise it to the power 12. And 16 is the same as 4 times 4 raised to the power x. Alright? Now we have this product having this power, all of them should carry the power. It becomes 3 to the power x, 4 to the power x. The same thing here, 4 to the power x, 4 to the power x, 3 to the x minus 4 to the x. Okay, coming this way, we see 4 to the power x is common. 4 to the power x is common, so we can factorize out 4 to the power x into 3 to the power x minus 4 to the power x is equal to 3 to the power x minus 4 to the power x. Now, we see 3 to the power x minus 4 to the power x on the left hand side and on the right hand side. So, we can just take this right hand side and bring to the left hand side, and then we'll continue our factorization process. So, we have 4 to the power x into 3 to the power x minus 4 to the power x minus 3 to the power x minus 4 to the power x equals 0. So since 3 to the power x minus 4 to the power x is common, we can factorize it out into 4 to the power x minus 1. We end up with this expression. This expression multiplied to this expression giving us 0. That can only happen if either this is 0 or this is 0. So we say either 3 to the x, let's first of all start with this one, either 4 to the x minus 1 is 0. And if that is the case, it means 4 to the x is equal to 1. When do we have this being true? We can change this one to an index form whose base is 4. 1 can be written as 4 to the power 0. So we have 4 to the x equals 4 to the power 0. Now this index expression equal to this index expression, the bases are equal automatically, the powers must be equal. So the value of x is 0. Right? So or we'll now take this other one, 3 to the x minus 4 to the x equals 0. Now look at this. Here we don't have the same base. There is no way 3 to the x can ever be equal to 4 to the x. So when do we have this subtraction giving us 0? When? That should be the thinking. And so the only way forward is by testing values. By testing values for x. Alright? Alright, so we start with 0. When x equals 0, what do we have? We have 3 to the 0 minus 4 to the 0. That will give us 1 minus 1. That gives us 0. It means that x equals 0 is a solution. That already confirms because we already had x equals 0 there. And let's check. What about when x equals 1? When x equals 1, we have 3 to the power 1 minus 4 to the power 1. That will give us 3 minus 4. And this is negative 1. Negative 1 is not 0. And if we look at it carefully, the subsequent powers of x right? Moving from 1 to 2 to 3 and so on, we will never have 0 because 3 to any power will never be the same value as 4 to that same power. So our conclusion is that the only solution to this index equation is the solution x equals 0.